Okay, we're going to see, we're going to look at section 5.6 and some of the problems that you're going to see in this week's homework and see if I can't help you out. The first thing is that you're going to look at the number system again and all of the different types of numbers. So I kind of gave you a number line here, and on this number line, you will see different things, all of the different types of numbers. So first, if we look at, say, the natural numbers, then the natural numbers on here are in red. And so, so if you just look, those are like counting numbers, 1, 2, 3. Even though this says the square root of 16, the square root of 16 is really 4. So, you know, sometimes these numbers are disguised, but those are the natural numbers. The integers take all of those natural numbers and they also add in 0 and all of the negative counting numbers. So negative 1, 2, 3, 4, and so on. Then you have the rational numbers. Rational numbers are any numbers that can be put into fraction form. So really remember that all of these natural numbers can be put into fraction form. So like 2 over 1, 3 over 1. And so that's why they are also, the natural numbers are also rational numbers, as well as the integers are rational numbers. But then the rational numbers also include any of the fractions, the other fractions that go in between. So we could have 1/2 right here, and that would be a rational number. Also, repeating decimals, those are going to also be rational numbers. Okay, now the irrational numbers are those weird numbers that kind of go in between. So we have pi right here, which remember we said that irrational numbers are numbers that are in decimal form. They don't end. They just keep going forever. Also, the square root of any prime number is going to give you an irrational number. Okay, you put all of these things together and you get the real numbers. So I'm going to give this to you in a different format. We've talked about this before, but so that you'll have it in your notes. So really, you start out with the natural numbers. So your natural numbers, remember, are your counting numbers, so on. Now, then your next one is going to be your integers, which is z. Okay, now z is going, remember, it adds in 0 and it also adds in all of the negative numbers. So we have like -3, -2, -1, 0, 1, 2, 3, and so on. So all of the natural numbers are also integers. So that's why this natural number box is inside of the integer box. Okay. All right. Then the next one is the rational numbers. Remember that the rational numbers are going to put in all of the pretty fractions and repeating decimals. So, you know, you would have like -3, -2, -1.5. That would be 1, -1, 0, 1/2, 3/4, and so on. Okay, so pretty numbers, pretty fractions, and also any repeating decimals. Okay, then you have your irrational, which irrational is going to be one of these that, let me erase that last, because irrational is one set that does not contain the other sets. Okay, so it doesn't kind of work, it doesn't work that way. All right, so really irrational numbers are kind of out here on their own. They're separate. So they call that Q prime. So that little mark there, quote, what do you call that? Apostrophe mark. That's called Q prime, which is the irrational numbers, is how they want you to refer to those. So these are going to be like pi, the number e, square root of 2, square root of 11. And remember that you can check those. So like if you were to do 11 and then take the square root, you're going to get this really, really, really long decimal that actually never ends. Okay, so so again, the irrational numbers, they're kind of they're off on their own. Now, when you put all of these things together, so here's a big box, which includes everything else, you get a real number. Okay, so the real number has all of these things, the rational and the irrational. All of these numbers are also real numbers. Okay, so hopefully that helped you a little bit. Now we're going to use this chart that we just made to look at this example. And on these examples, we want to label like 21. I want to know all of the different categories that 21 will fall under, all the different types of numbers. Okay, so 21 is a counting number. So I know that it's going to be a natural number. All right, 21 is also going to be an integer because the integers contain all of those. So it's also going to be an integer. Now, 21 can be written as a fraction, 21 over 1. So that means that 21 is also a rational number. Now, if you are rational, you cannot be irrational, all right? So 21 will not be irrational, but 21 will be a real number, okay? Because it's included in this whole big box. Okay, now let's take a look at 4.71. Now, the number 4.71 is not a counting number. It's not an integer because the integers don't have any decimals. And then you have Q, which is your rationals. So rational numbers are pretty decimals as well as fractions. And this is a pretty decimal because it ends. So this is actually, that's a rational number. And remember that all rational numbers are also real numbers. Okay, so remember, if you're rational, you cannot be irrational. All right, so that's all that 4.71 gets. Now we have 2.62626262. Now we can rewrite this as 2.62 repeating. If you can write this as repeating, then you are going, you know, that's what we consider a pretty decimal, which is a pretty fraction. It can be written in fraction form. So this is also going to be a rational number. It's not a counting, it's not an integer, but it is going to end up being in this rational box. And if you're rational, you're also real. Okay, and that's all there is to that one. Now, if you had the number, say we were looking at pi, and if you were looking at pi, then pi would be an irrational, so it's Q prime. but pi is also a real number. Okay, so all of these are real numbers as well. All right, so you're going to have some on your homework that ask you to do define those groups. So that's how you do that. All right, then you're going to have a couple of, I consider these to be pretty easy. They want you to express the number as a decimal and round your answer to 4 decimal places if you need to. So the easiest way to do this is just to grab your calculator. Okay, so I'm going to grab my calculator and I am going to do 1 divided by 7, because this is 1 over 7, which is 1 divided by 7. And then I'm going to make it negative, and there is my answer. Okay, so 1/7 is this number, 0.14285. Now, you want to, I'm going to write this out, 0.14285, was it 7 maybe? Yeah, 7. Okay, so it says to round to 4 decimal places. So if you go 1, 2, 3, 4, what you do is you look at the very next number. Okay, so the next number here is 5. If that number is 5 or higher, then you round up. Okay, 4 and below, it stays the same. All right, so that means that this 8 is now going to turn into a 9. So it's negative 0.1429. So that would be what you enter into WebAssign, because they wanted you to do 4 decimal places. All right, so let's look at 55 over 1100. So it's 55 divided by 1100. So when you do that, you just get 0.05. Okay, so 0.05. You don't have to, so because this didn't go out to 4 decimal places, you just leave it as 0.05. All right, now we're going to go the other way. Okay, so now they want you to change the terminating decimals to fraction form, and they want you to simplify your answer. So the easiest way, so some calculators, I don't know if this one will do it or not. Some calculators will change from fraction to decimal for you. I don't think this one will. But I'm going to show you, it's not hard to do this. So if you have to look at your place values. So remember that you have, so you have 0.6. So if you have 1 decimal, then that is your tens place. Okay, so that is going to be, so 1 decimal is your tens place, 2 decimals is your hundreds, 3 decimals is your thousands, 4 decimal is your 10,000, and so on. So we can write this as 6 over 10, okay? And if you need to check that, if you're not quite sure, you can just put it in your calculator, 6 divided by 10. And you get 0.6, okay? So now they want this in fraction form and they want it simplified. So in order to simplify this, we're going to do what we did in the previous section. So we're going to divide this by the greatest common factor, which is 2 in this case. So if we divide by 2, we get 3 over 5. And this would be your answer, 3 over 5, would be what you want to put into that math add type. And so remember, you have to choose the fraction. So you have to choose that like box thing like that. And then you can just type in the top one, click in that top box and put in a 3, and then click in the bottom box and put in a 5. All right, so 2 decimal places is the 100ths place. So this is actually 62 over 100. All right, now if you're not sure about greatest common factors, what I usually do is if they're even, I just start dividing by 2. So if we just divide top and bottom by 2, this would be 31 over 50. Okay, now 31 is, there's nothing that will divide into 31. So that is going to be as simplified as it gets. All right, 3 decimal places is over 1,000. So we have 628 over 1,000. And you can, you can divide by 2 until you get it simplified. So 628 divided by 2 would be 314. And then 1,000 divided by 2 would be 500. All right, this is still even. So I'm going to divide by 2 again. All right. And if you, don't be ashamed, if you need to use your calculator, use your calculator, okay? So 314 divided by 2 would be 157. And 500 divided by 2 is 250. All right, now I'm trying to figure out if anything will go into 157. And I don't think that it will, but you can always just check it. So like if you wanted to, say we wanted to check this and we wanted to go to Google and we wanted to say, what was our number again? 157. So we can look at 157, not 257, 157 prime number. And so as soon as I put that, it says that yes, that's a prime number. Okay, so again, we have lots of technology. Let's use it to our benefit. All right, so since that is a prime number, this is as simplified as this is going to get. All right, so that is going to be those questions. All right, now properties. This is going to take a little bit. Some of these properties we've already talked about, and they're not too difficult. But then we have a couple of new properties, which is going to take a few minutes to explain. All right, so associative property, I'm just going to use this with some numbers to help you realize, remember that associative property, let's say you have 3 numbers that you are adding, okay? Let's say 2 plus 3 plus 4, okay? So the associative property says that 2 plus 3 plus 4, it doesn't matter if you add these 2 first and then add 4, then it would be the same thing as if you were to add 3 plus 4 first and then add 2. So remember, I taught you this by saying it doesn't matter who you associate with. So this is my friends property. So you can be friends on either side with addition and with multiplication. So that's the associative property. All right, now commutative. Commutative, remember we talked about commuting. So you have commutative for addition and multiplication. So this just says if you add 2 plus 3, it's the same thing as 3 plus 2. All right. It also works for multiplication. 2 times 3 is the same thing as 3 times 2. All right. So you can swap those around all that you want. Okay. Now distributive. So the distributive property is dealing with multiplication and addition. So let's say that you had 2 times 3 plus 4. Now, what the distributive property says is that this would be the same thing as if you were to say 2 times 3 plus 2 times 4. Okay, so you distribute. And you'll oftentimes see people would draw those arrows. Okay, now we have these two new ones, identity and inverse, and I'm going to need some more room to kind of discuss those. All right, so the first one we're going to talk about is identity. So your identity property, you have identity properties for addition and multiplication. So when we talk about addition with identity, the key number here is 0. And then when you talk about multiplication, the key number is 1. So 0 and 1 are two very famous numbers in math. And the reason is because we can disguise 0 and 1 in a lot of different ways. So, and I'll show you kind of what that means. So the identity means that you can take any number. Let's say we take the number 6. And we can add some type of number to this. And whenever you add that number, you can get 6 back again. All right. Now, when that number we know is 0. Okay. So whenever you're adding, the famous number is 0. So it's just that whatever you start with, you can add some number that is 0 and you get back what you started with. So it's like you have not changed your identity. Okay, your identity remains the same. And let me show you how this can be disguised. Because let's say we took 6 and I'm going to add 4 minus 4. So now 4 minus 4 is a way that we disguised 0. Okay, so 4 minus 4 is 0, but it looks different, right? So this problem, this second problem, looks different than this first problem, but you end up having the same thing. So that's why 0 is that identity. I can also rewrite this as 6. I could say plus x squared plus a negative x squared. And I'm also going to get 6 because this is just a fancy form of 0. I took x squared and I added the opposite to it. And when you add opposites together, you get 0. Okay, so I know that's confusing, but basically the identity for addition is that you add some form of 0 and you get your number back again. All right, now multiplication is similar, except that what you do here is we're going to multiply 6 times some number and we're going to get 6. Okay, now the secret number for multiplication is 1. So I can just say 6 times 1 is 6. But now remember, 1 is probably the mathematician's most favorite number to be a disguise, because any number over itself is 1. So I could say 6 times 4 over 4. 4 over 4 is 1. But just to prove this to you, to show you that I'm going to get 6 again, if you remember, we take 6 and we can put it over 1. So we have numerators and denominators. You just multiply. And you get 24. 6 times 4 is 24. 1 times 4 is 4. 24 divided by 4 is 6. So again, I just disguised 1 and I made it look different. So these are the identities. So let me show you one more. Let's say we had 6, and I'm going to make this one really ugly. Let's say x squared plus 3 x minus 256. If I put that all over itself, x squared plus 3x minus 256, guess what? This is just a disguise of 1, okay? So that right there is equal to 1 because any number over itself is 1. Anything over itself is 1. So 6 times all of this mess is going to end up giving you 6 again. All right, so this is the identity property. The identity property says that there is a number that you can add. So take any number and we can find a number to add to it that you get that number back again, that original number back again. That number is 0 in any fancy disguised form of 0. Then the identity for multiplication is that we can multiply any number by 1 and get that number back again. And remember that we can disguise 1 into looking like totally different things, okay? All right, so that's the identity property. Now the inverse property is very similar. All right, so inverse property. Now the inverse property means it basically is it goes along with, so when you have inverse for addition, it also has to do with 0, and for multiplication, it also has to do with 1. So, but what the inverse property says is we kind of rearrange it a little different. We say that we can start with 6, we can add some number to 6, and we get 0. All right, so up here, notice we added 0 and we got the original number back. But in this case, we're looking for the inverse of 6, okay? Which for addition, it's the opposite of 6. The opposite of 6 is -6. Okay, so this is, they call this number, whatever number goes here, they call that your additive inverse. All right, so it's just rearranging the same thing. So you get 0. So we could say x squared plus a -x squared, because that's the opposite of x squared. And whenever you add those together, you get 0. All right, now you also have this for multiplication, and instead you're trying to get a 1. So if you start with 6, we are looking for the multiplicative inverse, which is the number that you would multiply 6 by to get 1. And this is called, this one, you know this as reciprocal. Okay, this is opposite. The addition part is opposite. The multiplication part is reciprocal. So the reciprocal of 6 is if you make it into a fraction, you just flip that fraction over. Okay, so so we can take 6, we can multiply it by 1/6, and you're going to get 1. We can take x squared. We can multiply x squared by its reciprocal. So we can also put x squared over 1. And then the reciprocal, you just flip them. Okay, so it would be 1 over x squared. And that gives you 1. All right, so that is your inverse and your identity, okay? So just remember that the identity is you start and end with the same number, okay? The inverse is going to be that you're adding 2 numbers to get 0, or you're multiplying 2 numbers to get 1. All right. So that's identity and inverse. And we're going to look at one more example from your homework. So this one talks about operations and groups. Well, no, we have two more. So, all right. So they want to know if this group, which Z, remember, is our integers. And remember, our integers, again, are going to be like the negative numbers, negative counting numbers, 0, and then all of the positive counting numbers. Okay. So they want to know if this set, whether the set and the operation form a group. So to form a group means that if you take any two elements, perform the operation, and then your answer will be in the group, will also be in the set. All right, so here's my set. My set is all of my integers. They gave me the set. And they want to know if this will form a group for addition. So basically, if you take any two elements from the set and you add them together, that the answer is going to be also in that set. So let's just try it out. Let's take -3 plus 2. Okay, so we're going to add two elements from the set. So a -3 plus 2. -3 plus 2 is -1. Now, is -1 also an integer? Yes, it is. So it worked here. Now, I usually like to take, so I'm going to say -3 plus a -7. Okay, so I'm going to do two negative numbers here. So -3 plus a -7, that's the same thing as -3 minus 7, which is -10. Now, is -10 also an integer? Yes, it is, because it's one of the negative counting numbers, okay? Now, I'm also going to check this for two positive numbers. Let's just say we take the positive number 3 and we add 6 to it. Okay, 6 plus 3 is 9. Again, we are checking it for addition each time. All right, 6 plus 3 is 9. Is 9 also an integer? Yes, it is. So it looks like if you take any two elements from the set and you add them together, your answer will also be in the set. So the answer here is yes, this forms a group. Okay, so that's what it means to be a group. All right, so I think that your homework is just going to be yes or no. You know, is the answer will just be yes or no. Okay. Now, the last thing is that they kind of throw in these weird looking notation. So this says to let this triangle, which triangle in this case is actually delta, but I'll just say it's the triangle. Let the triangle be an arbitrary operation. Now, an arbitrary operation means it could be anything, okay? They want you to describe this operation for the problem that you see below. All right, so we're trying to figure out what operation is the triangle, okay? So we're trying to figure out what that operation is. So what we're going to do here is we are going to look at 5. So whatever this operation is, 5 triangle 3 gives me 2. Well, I know that 1, and that has to be a mathematical operation. Like it has to be either plus minus, it has to be multiply or divide. So it has to be one of those. All right, so I'm trying to figure out which one it is. All right, so I have 5 triangle 3 is equal to 2. Well, I know that 5 minus 3 is equal to 2. Okay, so let's see now. So my original hunch is that this is probably going to be minus each time. So they've given you 3 different operations here. So we want to make sure it works for each one. So 6 minus 1, does that equal to 5? Yes. And 9 minus 6, does that equal to 3? Yes. Okay, so here, what we want, let me check one thing. Let me pause. Okay, so I wanted to double check and make sure how they want your answer. So I checked that out. So basically, we're going to put in some letters because, of course, that's what we do in math to make things confusing. So we're going to say A triangle B. What does that really mean? So that means then that this is A minus B. All right, and this is what they're looking for. I think these will be multiple choice, so you should be fine. But that would be your answer, is that triangle means subtraction. Okay, so all right, so that's everything in 5.6. Hopefully that helped to clarify a few things. You may have to replay this a couple of times and so that you can really get a grasp of it. If you have problems, as always, just let me know.